We wish to compute this limit, and as usual with such simple limits, our first attempt should be to plug in. If we find a meaningful quantity after plugging in, for such good functions, this will be the limit. But here we find 0 over 0. So we don't deal with polynomials, so there's not going to be a synthetic division, at least immediately. What we need to do is try to create the quantity x minus 1 on the numerator. And how do we do this? Please note that if we had, instead of x plus 3 minus 2, if we had the difference of the squares, that this would immediately be x plus 3 because the square root cancels with the square minus 4, which is x minus 1, if only we have the difference of the squares. So then the question that comes up is, if you have the difference of two things, what do you need to multiply by in order to get the difference of the squares? And we have this very simple identity known as the difference of squares identity that tells us that the difference times the sum is equal to a squared minus b squared. And in this case, we sometimes call it the conjugate quantity. So this is called the conjugate quantity of a minus b, and that's the conjugate quantity trick. The important thing to understand is that we cannot just multiply out of the blue with a quantity on the top. We need to balance things out by also multiplying the bottom, because whenever we have a fraction and we multiply the top and the bottom by the same thing, the fraction remains the same. It may look different, but at least it is equal to what we had before. So let's put all these things together in solving this problem. So we start by writing the limit. And then we execute as we just described. So we multiply on the top and the bottom by the sum. And what we will get on the top, so think of this as our A, this as our B, so we have A minus B times A plus B. So according to this identity, we'll get the difference of the squares. So this will be the limit as x tends to 1 of the square of x plus 3 minus the square of 2 times x minus 1 So this is going to give us x plus 3 minus 4 over x minus 1 and this will further give us x minus 1 over x minus 1 times. And now the idea is to perform the cancellation. We have to here be careful about the fact that what will remain on the top is just the quantity 1. Why? Think about it as this times 1, which is always something that you can suppose. And so once we get rid of the x minus 1s, that will give us the limit as x tends to 1 of 1 over square root of x plus 3 plus 2. And finally, we can plug in. And we have, oops, once we plug in, we should get rid of the limit notation. That's exactly the point where we do that. And that will give us 1 over square root of 4 plus 2, which is the same thing as 1 over 2 plus 2, which is 1 over 4. So notice that we keep the limit notation all the way till the point that we plug in. Once we plug in, we should actually get rid of it. Please also note that such a problem can be done using L'Hopital's rule, but this is not available at this point in our course, and we prefer to actually do it in a more elementary way. And that's all. Thanks for watching.